Okay, so today I'm going to explain and also review the entire chapter 1 functions of additional mathematics in Form 4. So here I'm going to go through what is function and how we're going to use them in chapter 1. So if you take a look at functions, basically if you go back to maybe Form 3, you can see, or Form 2, there's a chapter about sets. Now what sets means is that there are multiple relations that can correlate one thing to another. So there are 4 relations, okay? 4 relations. We're going to go through one by one. One is a one-to-one relation. Another one is a one-to-many relation. The third one is a many-to-one relation. The last one is a many-to-many relation. What does this tell you? A one-to-one relation means that one number can be mapped to another number. For example, maybe 1 can be mapped to 2. A one-to-many relation means that this number can be mapped to multiple numbers. For example, this can be mapped to 5, 6, 7. A many-to-one relation means that a few numbers can be mapped to one number. Okay? A many-to-many function means that many numbers can be mapped to many numbers. For example, one-to-many, and then connecting, and connecting. So this is a many-to-many function. Okay? That's the concept of relations previously taught. Then here in functions, there's only 2 relations that can be used, and then the answer must be with only one element. So as we all know, on these axes we have 2 axes, one x-axis and one y-axis, which means that whatever is here will respond to the y-axis when it comes to the numbers. So here there are only 2 relations that can be used with our functions. That will be one-to-one and many-to-one. Okay, anything else that has a many at the back? No, they cannot be used as functions. Okay, your answer must only have one element. Okay, there cannot be more than one element for a function. Okay, I'll give you a very good example, or a better example. For example, okay, so in functions you'll see this often. It's called function of x. Function of x. What is function of x? Function of x basically is y. So whatever number that you put on x, it will have a direct correlation with your y-axis. So in that case, it can be known as function of x, or you can just call it y. Okay, it doesn't really matter at this moment. For this one, let's say for example you have fx. I should give you a coordinate. For example, a coordinate of 2 and 4. Okay, so fx, since we know is y, so our y is 4. Okay, so how do we get this number? So there must be an equation. Since we know that our y is 4 and our x is 2, so that means that there is a way to get this number. So for example, in this case, y equals to x equals x squared. So if you use x squared, you can get this. So whenever we go up on this line, we'll know that every time when the number increases, it has a direct relationship with y equals to x squared. So for example, what if our y is a 16? Okay, number is 16, so that means if it's x equals square, and then when we square root the answer, we get this, and then we get plus minus 4. Positive negative 4 equals to x, so it can either be positive 4 or it can be negative 4. This is for our function. So this one here, the x itself can either be 4, it can be negative 4. That's why many-to-one exists, because there's always only one answer for our y-axis, but for our x-axis it can be multiple answers. So here, good example, that would be a positive and a negative number. Okay, so this is that for our function. So let's move on to the next one, which is our composite function. What is a composite function? So let's give you a good example. Composite function. So we have 3 sets. So here, this is our x. This can be y and this can be z. But there's no way we can actually use y and z as a representative, because later on you'll see that will be a problem in equations. So instead of this, we'll use fx. And then this one maps there, so this is a function. And then this one here maps to g. Let's just continuing on with our continuous list of alphabets. So this one will be a g, f, and an x. Okay, so that means that this function maps this to this, and this function as this to this. So in this case, these two functions will map from here all the way towards our z. Okay, so that means that these relations, they can be connected together using two or three functions. Okay, so they can be even more if you wanted to. Okay, and then let's take a look at inverse functions. Inverse functions. So I give you a good example. So this one is our f inverse x. This is an inverse function. Okay, so now we have fx equals to maybe 3x plus 5, for example. So this is our y. Now I want to get back my I want my function to be inverse, like completely upside down. Okay, that's what inverse function mean. I want my x. I want to know how to get my x. So y equals to 3x plus 5, and then we move the 5 to the left. That will give us y minus 5 equals 3x, and then we divide, we get something like this. And then here, our x here is actually equals to f inverse of y. Why? Because first of all, fx is basically y. So when you move to the back, that basically means that we are doing an upside down function. So when it's an upside down function, we will get the power -1 for the y equation. So here it is f inverse 1 y. And then here we need to switch the y to x. So this one is x minus 5 over 3 equals to f inverse x. This is our inverse function.